My name is Marshall Hussein Schuler. I'm happy to have this opportunity to introduce the work of my colleagues and myself to you today about our paper entitled Visually Cued Action Timing in the Primary Visual Cortex. This work was done by the lead author Vijay Nambudiri at Hopkins in conjunction with our colleagues Marcos Huertas and Terrell Cheval at the University of Texas, Houston. The general issue was how one goes about generating timed responses in response to environmental cues. The canonical view of how such behavioral response is produced by the brain is through a hierarchical process mapped onto a sensory area for detecting this sensory world and a region for making the decision about how and when to time a response, and the production of the motor action itself, as one might find in motor cortices. However, this notion of hierarchical processing and behavior generation has somewhat been challenged recently by emerging observations, even within primary sensory areas, of them doing much more than faithfully representing the world, and in this case, the visual world. Exemplifying that is the phenomenology of reward timing as observed in the primary visual cortex, V1. Reward timing is the case where pairing a visual cue with a subsequent delayed reward causes the emergence of neural activity that comes to report the expected delay to the reward given the presentation of the visual cue. Given this interval encoding and representation within the visual cortex, we pondered whether or not it could actually be used by the animal to inform a visually cued timed behavior. To address this question, we trained animals to play a game of receiving a visual cue and then having to produce a timed action, in this case a timed lick on a lick tube, in an effort to achieve or maximize the amount of reward that they would receive on that trial. And in that way, the animals, through a trial and error process, would come to learn that the cue meant future reward, but more importantly, that they had to time their behavioral response, licking, appropriately given the delay from the visual cue. In this way, we could assess their actions on any given trial and compare it to neural activity recorded within the visual cortex at the same time. As before, we observed such reward timing activity, but we also, and much more interestingly, observed so-called action timing activity. And this is the case where neurons appeared to report the interval in which the animal was then to produce in its response, as if that activity was actually informing the animal's notion of when the target interval had elapsed. In this way, on any given trial, the brain might generate a different notion of how long that interval was, or its ability to produce that interval might fluctuate from trial to trial, and in that way too you would see a fluctuation in the behavioral report of the expiry of that interval. The question then became whether or not this action timing activity co-varied with the time in which the animal would then subsequently report the end of the interval. And that in fact was what was observed. That lends credibility to the notion that this neural activity is actually being used by the animal to inform actions. However, if it were the case, then one should be able to perturb the activity from the offset of the visual cue within the visual cortex, but prior to the animal's production of the expiry of that interval. If that activity was actually going on to inform the animal when the interval expired, then such a perturbation should lead to a consistent shift in when the animal actually reported the expiry of the interval. We in fact attempted to do this by optogenetically perturbing the ongoing activity for a brief moment during the interceding interval, and then observed a consistent shift in the animal's behavior, leading credibility to the notion that in fact this activity within the visual cortex actually was being used by the animal to time its action. The consequence of these observations from a broad perspective is that even primary sensory areas, which are typically thought to faithfully reproduce the world, can be involved in much more rich behaviors, as observed here, even in the production of a timed interval and its action.